Hey, pre-algebra, we are in chapter 5. We're looking at multi-step equations and inequalities. And our first section is about perimeter and area. So let's take a look at some of our vocabulary. Our vocabulary, um, our vocabulary is filled with some familiar terms. I think all of you are familiar with the concept of a formula. It's an equation that shows a relationship among certain quantities. And we have formulas for perimeter and area. So I want to introduce some of those now. The perimeter, if we look at the perimeter of anything, it's going to be the sum of all sides, right? But if I'm talking about the perimeter in particular of a rectangle, we know that a rectangle has both pairs of opposite sides are the same. So I'd say 2 times the length plus 2 times the width would be equal to the perimeter of a rectangle. We can also talk about the area of a rectangle. The area of a rectangle is often given as length times width or base times height. Another formula that you should be familiar with is the area of a triangle. The area of a triangle is given as 1/2 base times the height. So these are formulas that we are familiar with, and you notice that we are relating a quantity such as the length and the width with the perimeter, or the area with the length and width. Let's take a look at the perimeter. The perimeter is a distance around a geometric figure. So as we discussed briefly, if we're looking at a rectangle, we know that the rectangle can have a width and a length. And let's say this particular rectangle has a width and length of 3 and 7. If we wanted to find the perimeter, we would have to add up all of the sides, as our formula indicates. The area is the measure of the surface enclosed by a figure. So if I had, let's say, a triangle, and I wanted to measure the area, I'm not talking about the side lengths. I'm talking about how much space. Usually we talk about it in square units, square inches, square centimeters. I'm talking about how much space is covered by that triangle. So in a way, when I think about perimeter, I'm thinking about putting up a fence and how long that fence is going to be around a particular place. And when I think about area, I'm thinking about a rug. How much space on my floor will it cover? Let's take a look at example 1. Here in example 1, we're going to find the perimeter. In this case, it's a triangle, so we don't exactly have a formula for finding it, but really it's pretty simple. We're going to add up all the sides. So we're going to start off with one side, which is 5.2 inches. And units are important, so I'm going to make sure and keep my inches with me. And 7.8 inches, and then 5.4. When I add these up, remember when we add decimals, we need to make sure that the decimals are lined up. So we get a 14 here, carrier 1. When I add up all of these, I end up with 18. So my answer is 18.4 inches. Notice, since we're talking about that fence, I'm not going to talk about square inches because this is really just straight inches. So when we talk about perimeter, we're really talking about inches or feet, not feet squared, as we will when we talk about area. Here in example 2, we are going to find the length. It says the perimeter of a rectangle is 42 feet. If its width is 10 feet, find the length. Whenever I have a problem like this, I really like to draw a picture to really give me a sense of what's going on. So I start off by simply drawing a rectangle and indicating whatever information is given here. We're told that the perimeter is 42 feet and the width is 10 feet. We need to find the length. I'm going to use an L for the length, and I'm going to use 10 for the width. I could use W, but since I was given the information, I'm going to use what I got. Before we looked at a formula for finding the perimeter of a rectangle, we said that the perimeter of a rectangle was equal to 2 times the length plus 2 times the width. In this case, since we know what the width is, it makes perfect sense for us to replace W with 10. So 2L plus 2 times 10 is going to help us create an equation that we can actually use to solve and figure out the length. I'm going to put 42 in for the perimeter because that's what we were given. When I do that, I have an equation that we should be pretty familiar with. We can solve equations with one variable. Pretty simple. I'm going to subtract 20 from both sides. And when I do that, I'm left with 22 is equal to 2 times L. And when I have this, I know that I'm going to divide both sides by 2, and I get that L is equal to 11. So in this case, L is equal to 11. That's the length. But here's the thing. Don't forget, we're talking about feet. So our answer isn't just 11, but 11 feet. And I can use that abbreviation. In example 3, we're going to find the area. It says the base of a rectangle is 12 inches and its height is 5 1/4 inches. We're going to find the length. I think this actually should read area. Let me take that out. I think that was a mistype. All right, so we're going to find the area. The base of a rectangle is given and its height. Again, whenever you have a problem like this, it's really helpful to draw pictures. So I'm going to draw what I have. I'm given that the base is 12. And I'm given that the height is 5 1/4 inches. Don't be afraid of fractions. We just had a whole unit in figuring out how to multiply these guys together, so we should be perfectly fine. So when I'm looking for area, I need to use length times width because I'm looking for the area of a rectangle. I'm going to do length times width. In this case, or base times height. Remember, we looked at it in both ways earlier on. So when I do that, I'm going to do 12 times 5 1/4. When we multiply improper or mixed numbers, we like to change them into improper fractions. So we're going to write this as 12 times, 5 times 4 is 20 plus 1, 21/4. I don't know about you, but I am into cross canceling because if I get to cross cancel, it helps me have an easier time with my multiplication. So I realize that 4 goes into 12 and 4, 1 time here, 3 times here. Now my answer is pretty simple. It's 21 times 3, which is going to give me 63. Not 63 inches, however. When we're talking about area, we're talking about how many little tiny squares are here, in this case, square inches. So this 63 does not refer to a length or a width, it refers to an area, so we call them inches squared. Here's our final example, example 4. We're going to look for the width. Here's the given information. A rectangle has an area of 800 square inches. If the length of the rectangle is 120 inches, what is the width? Again, I love drawing a picture. So I'm going to draw a picture of this rectangle. And since I can't really put 800 inches on the side, I'm going to put 800 inches squared right inside to keep me focused that the area is 800 square inches. The next thing I'm going to do is to indicate a side, which is the length. So this side, let's say, is 120 inches. If this side is 120, so is this side. And I need to find the width. Let's put W here. Do you guys remember the formula for finding the area? We just use it. Area of a rectangle is equal to base times height, or length times width. So what we'll do is we'll use that to help us answer this question. I'm going to plug in everything I know. I know what the area is. It is 800. So I'm going to put 800 here. The base or the width, I'm not sure of, but the length, I know it's 120. So right now I have an equation with one variable, which we're really good at solving. So 800 is equal to W times 120. Since these guys are being multiplied, I'm going to divide to isolate W. So I know that 10 goes into the numerator and the denominator, and also 4 goes into each. So 4 goes into that 20. So my answer is going to be 20 over 3, which can be reduced to 6 2/3. But you guys know very well that 6 2/3 is not the answer. The answer has to be 6 2/3 inches. So I'm going to put, let's see if I can actually write that. I'm going to put a little inches right here because we're talking about a length, not an area. So we can simply put inches. All right, good people. Our final bit of information here is just the assignment. So we're looking at pages 224 to 225, 4 through 9, 13, 14, 16, 18 through 23, 26, and 27. I look forward to seeing you guys tomorrow.